Hello everyone, welcome back to my channel. In this video we are going to be looking at how to determine psychometric qualities of multiple choice item under the classical test theory approach to testing, and the package we are going to be using is the CTT package. In one of our last videos we looked at determining psychometric quality of test item using the psychometric package. The psychometric package does not have the capacity to provide us with distractor analysis. That's why we are using this package CTT, as the package has the capacity to provide us with distractor analysis and other additional analysis that can provide more information about our item. Now, what are we going to do here in this video? We are simply going to be looking at what this package can do. So the package can help us to obtain the total test score of our students. The package can also help us to find score on each item, find the test reliability, can also help us to find item analysis, talk about difficulty, discrimination and all of that, and it can as well help us to determine the quality of the distractors, and also we can also use this package to plot the item characteristic curve. So without wasting time, let's dive into the analysis proper, how we can use this package. The software we will continue to use in this series is RStudio. So we should go ahead and open our RStudio. But before we do that, it's important that we make ready our data that we'll be using for the analysis. Two data sets are important for this particular analysis. The first one is the data set that contain the item responses, and the second one is that data file that contain the keys to each of these responses. You remember in the last video we always call the item as correct and incorrect, but in this case we are going to be using just the responses. So we have looked at how to convert our data set to CSV format, which is readily acceptable on R. If you don't know how to do that, you can check one of our videos where how data can be converted to the CSV format was duly and properly treated. Now, coming from that background that we know how to convert our data, we have this as our key, and this is the responses of the student. So another thing we have to do is, for any R analysis, it is important that we create a folder. So the first thing you want to do is to create a folder. So I'll call this folder. I click on your desktop anywhere on your system. I prefer my desktop, that's why I'm always using the desktop for any new analysis I want to do. So I click on new folder, then I give it a name. Let me just call it CTT underscore ANA, and then I press enter. So the next thing for me to do is the data that I'll be using for this analysis is for me to put it inside the folder I've created. After that is done, can go ahead and begin with the analysis. So how do I go about that? The first thing, to get that done, you have to open your RStudio, and to open RStudio, all you just have to do is to double click it on your desktop or wherever you have it. You have the RStudio. Just locate the RStudio and open it. So if your RStudio open correctly, this is what you are going to have. Whatever is the last thing you work with on your RStudio will be there. Another time you are opening it up, but you can clear the console. So you can just clear everything. This is the last data I used, so So remove the data. You can as well clear whatever you have here. How do you get that done? You just go to edit and you click on clear console, so you have a blank slate. You want to begin. So the first thing we want to do for any error analysis is that we want to check the working directory to just get information about where is working from, and then press enter. After that is done, we can see it's working from the document. So we have to change this working directory to the folder we created on our desktop for this particular analysis. And how do I do that? I'll just go to section. From section, I will click on set working directory. Then I will then click on choose directory. After that is done, it will redirect me to locations on my system where I can locate the folder that I want to use. This folder is on desktop, so I will click on desktop at this end. Then the one I want to use is CTT, and that's where I have my data. If you click on it, if you just hover around it, it will show you that in this file you have two files there, key and phy. So we are good to go. So we'll click on it. After clicking on it, you need to ensure that the same data file you have here is what you are having down here. So you click open. After that is done, you are good to go. Your folder has been redirected to the folder you created for this analysis. So the next thing we want to do now is to bring in the data file that contain the item responses. So I will click on import data set here. If you can't find it, make sure you click on environment. Once you click on environment, you will find import data set. So you click on import data set. From there, you choose the very first option, which is from test in brackets base. Click it, and then it will redirect you straight to the folder. And when you get to the folder, click on the data that you want to bring in, which is the one with the responses. So you click open. After clicking open, it's going to ask you, does your data have a header? Yes, our data has a header, so we click yes, and we can go. So in the option of any, because of the peculiarity of this analysis, the NAs are the omit, OM that we can see here. OM that we can see here. So all of that is important. You want to see how many items were not also picked for classical test theory, because you want to describe the situation so that you can judge the quality of the test item and also the quality of the distractors. So that's done. We are not going to indicate the omit, because when we indicate, the analysis may not go out well. That's why we use OM. So you leave the NA as it is, don't change it. And when you are preparing your own data, make sure that you use value or alphabet to represent your missing response, alphabet that is different from any, so that it won't take it as missing, but rather it can show that it is omitted. So once that is done, you can click on import. So after clicking on import, you are good to go. Your data is imported to the interface. So we can go ahead and begin to write the code for this analysis. Now the next thing you want to do is the package you want to use for this analysis is called CTT. If it's your first time of using CTT package, then you have to go ahead and download the package. And how do you do that? To do that, you just under here on the right hand side of your system, you will see packages. So click on packages. After clicking on packages, then you can see install and update. Click on install. to install the package. So after clicking on install, this will come up. So you type CTT inside the rectangle on this pop-up. Type CTT inside this place, CTT. Before you are done typing, it will bring you the package so that you are sure you are correct, what you are typing is correct. So you click on it and then you hit install. So I have downloaded this package before, so I won't be downloading it again. For you that you are using it for the first time, click on install. And when you click install, okay, maybe we should go ahead. I should go ahead and click on install. Click on install and make sure that you are connected to the internet. When you do this, start clicking on install, you just wait for the package to download. Whatever you do, if your installation is done correctly, you must see CTT successfully unpacked and MDS5 checked. This is what will prove to you that the last thing you are going to see, you can see other things, other dependencies that would have been downloaded, but make sure the last thing you see before this particular download binary package and this is package CTT successfully unpacked. After that is done, you are good to go. You can begin your analysis. Now, one more important thing that you need is the key, because what you have here is the item responses, and the reason why we have the item responses is because we are also interested in finding how many students pick or how many respondents picked a particular option, because we need to also judge the quality of these options, extent to which they are functioning as distractors. All right, so for us to write this code, we are going to write a lot of code. It is unlike what we have been doing in the past, where we just type the code here on this line. We'll write a lot of code in this particular analysis. So for us to get that done, we will have to go ahead and open Arrow scripts. Arrow scripts is part of the Arrow Studio that will help you to write your code and you can run everything at the same time. So to do that, we click on File. After we click on File, then we click on New. And after clicking on New, these options will come up. On the options that come up, just click on Arrow Scripts. And when you click Arrow Script, you are going to find a blank console here at this upper part. And there you can write your codes. So the first thing that we want to write now is our key. I want to present our key. I want to present information about the key so that the system can use that key to mark the responses of the respondents. All right. So we type key, which is a name, and then put less than sign and hyphen in front of it. Type C, and then open a bracket. Inside the bracket, put your keys. So this key will be separated by comma, and they will be placed, each of them will be placed inside a parenthesis. So let's take for example that item 1, the correct option is C. So have this as C, and then comma. Item 2, let's say the correct option is E. So you put inverted comma, quotation mark, and put E. Depending on the presentation of your options, if you presented your options in the time when you were doing your coding, if these were presented in small letter, lowercase, you would indicate at this level lowercase. But you can see what we have there is uppercase, so we have to indicate the options are, if you put small letter c, lower c, it will take it at different variable. Don't forget, r is case sensitive. So we'll go ahead like that and type all your keys, but this can be time consuming, so it is our advice that you prepare your key in an Excel sheet and then convert it to CSV format. So the comma would have been included in the data set, so you just copy and bring here. Let's look at how we can prepare our key so that it can align with this particular format that we are expected to put it. So we should we should go to the desktop, and then our key, which is the key. So right click it and open it with a notepad. If you just open this way, if you just open it, you just open the Excel, what you are going to have is just simply the key in the Excel format, but we want it in a format that is exactly like what we have here. So let's open it with notepad. Open the key with notepad. So you open with notepad, this is what you are going to have. You can see the comma all included. So one thing to do at this level is to just copy only the key. Copy the key and then open a new notepad file and paste the key there. After pasting the key, we can then prepare it to be exactly like what we want. So how do you do this? All you just have to do is just find and replace so that it can be in this format. So what do? I'll just go to edit and then look for replace. So for every A, I'll start from A that we have there, I will replace it with inverted comma A, then close it to another quotation mark and then press replace all. I'll do the same thing for B. Let's be inside inverted comma, replace all. Do the same thing for C. Place it inside the comma and then replace all. I'll do the same thing for D. Inside inverted comma and replace all. And lastly, I'll do for E. So we have our data exactly like how we want it. So all we just have to do is to copy what we have here, copy it, minimize, and then come to inside this our bracket and paste what we have there. So we are good. Our key is done. The C you have here before this key is small letter, not capital letter. Don't forget, it's lowercase c. So the next thing we have to do is to now continue with the analysis. So the very first analysis we want to do is the scoring. We want to find the test score. We want to find the test score and the item score. So let me just write it. So the first thing is finding test score. So I put this hash here so that when I want to run the code, any line where you put hash will not, the system will take it as comments. So I'm just typing that as a comment. So for test score, the first thing you want to do is to give it a name. Whatever you are doing, whatever analysis you are doing on R, you always want to give it a name. So let's give the first one a name. So the first one is test score. Don't forget, R is case sensitive. So if you are using small letter or lowercase, use lowercase in all. Don't mix your letters in terms of cases. Then put less than sign and a dash. After that is done, you can then begin the code. The code to score is called score. Just type score. After typing score, you open a bracket. Inside the brackets, before we do that, let us call our package. Let's call our package, because calling the package will help us. It will help in typing the code. It can help correct the code. It can guide us to doing accurate analysis or writing accurate code. So let's call the package that we want to use. The name of the package is library. Is a CTT. So you type CTT, you type library, and inside the bracket you type CTT. So you press enter. So the package is active. So if I begin this again, you see it will suggest to me. I type score. Suggest to me, do I mean I want to do score? Yes, that's what I want. So type score. This score is lowercase. So inside this bracket, you have to now give it the data you want to analyze. What is the name of the data? This is the name, PHY. Don't forget, it's case sensitive. So you type PHY. So it will suggest to you, this is your data. By the time you click on it, you can always see that here. So, comma, your key. What is the name of your key? The key is simply key. That is what we prepare the first place here, the first instance here. So just type key, Y. Key EY, then type comma. So the next thing we now want to type is, we want to type output dot scored equals to true. So that is the code for the test score. After this is done, now when we run it, inside here we now have the total test, the observed score for classical test. So that is the total score obtained by each individual, and also the scoring for the items. So let's look at the total test score first. Total test score, or what you call the observed score under classical test theory. Total score. So will just be test score. Test score. This score that we have here, test score. Then you put the $sign that you have on your system that is sharing the same key with number 4. But whatever it is, locate your $sign on your keyboard. Type it then. And you type score. This will give you the total test score obtained by individual. Now for the item score, just scoring. This case is just like the case of what we did in psychometry that we use our Excel to do by marking it ourselves. Just having 1 and 0, 1 and 0, 1 and 0. Alright. And this will be done cross board for everyone that took the test. So every individual you will see the score on every item. That's the purpose of this particular one. So I'll type item score as a name, give it a name, less than bracket, and then I will type test underscore score, type the dollar sign. Instead of typing score, I will now type scored at this level. So we are good. That is the code for the item score. So before we proceed to other analysis, let's look at the output that we are going to get from this analysis. So the first thing you want to run, all of what I have here is just the code. I've not run any. So the first thing you want to run is that you want to run the key. You have brought in the data file, you are good to go. Because you also need the key for this code to run, you have to first run the code. So I'll run the code. We can see we don't have any problem with it. If there are issues, it will show you issues. So we are good to go. We can go ahead and run the code for the test score. I click on line 3, which has the code for the test score. Click run. We are good to go. The analysis concluded perfectly without any problem. So let's also run the code for the total test score. Click on that particular line and click on run. That is also fine. So you might want to see the outputs of your total test. And how do you do that? All you just have to do is to type the name of the analysis you have just conducted, and that is why we give every analysis a name when we need to extract the output, so that we can use the name to call the output. So the name is TOT underscore score. So just press this and then press enter, so we can see this. So it means that participant 1, which is P1, have a total score of 17. That is the answer, 17 item correctly. Participant 2, 19 item correctly, and all of that. You can export this output into the folder that you have created by simply typing sync in brackets double quotation mark and just say this is the test score. Maybe you say total test score, total score, then put the extension .txt and press enter. Then you type the name TOT underscore and press enter. So that way the output would have been saved in your folder. So you close what you have done by another sync. Just type sync and close it up. So you are good. So the next output we want to, the analysis we want to do now, or let's see, we have done, yes, the test score. So let's look at the item score. To do that, we have write the code for the item score. Just click on it and then run. So the item score had been done. So for you to, let's see what the output is. You just type the item, the name for the item score, and press enter. So you can see. So this is for question 1. This is question 2, question 3. So for the first participants, he answered item 1 correctly, item 2 correctly, item 3 correctly, item 4 correctly, item 5 correctly, but 6 he didn't get it right, 7, 8 correctly, and all of that. So you can see for each of your participants. But there's a problem here. It's telling us that the system omitted 183 row. There is a limit to what arrow can print out. So when you see this as a problem, you must tell arrow to print every output. So how do you tell it to do that? You just type options, in open brackets, and then type max dot print to bring it out for you. Max dot print. That means you will then quote a number that will be greater than the number of rows you have in that data set, or a number that is bigger than the expected output they are looking at. So we know that this is just around 200 rows. I can decide to say I'm putting 10. This is like 10 million or 1 billion thereabouts. So something bigger. Just type something bigger and press enter. So if I look at the item score again, you discover that it will print for me everything. So you can see now everything has been printed. So we have 199 that's printed the item score for every participant in the data set. All right, so that is that about the item score. So let's move on. The next thing we want to look at is reliability analysis. So let me also write a comment and say reliability analysis. Press enter. So the next thing I'll do now is to type the code for the reliability analysis. The code that we need here is from this place, but we quickly want to give this a different name. The particular code that we need, the input data set that we need for the reliability analysis, of course, the very first thing you want to do is that you give it a name. Maybe I should just call this reliab, and then that's the name I want to give, and then I type reliability. Type reliability to suggest it to you, so bring it. So the first thing you want to type here, the first and only thing that you need there is the data set that you want to analyze. But the data that this will deal with, because this particular one is the CUDA Researching 20 formula, the coefficient alpha, a measure of internal consistency. The particular thing that you want to put there is the item score, not the responses and the key, because it deals with those that are correct and what is not, the incorrect responses. So before we do that, we have to extract the responses and give it a name. So for us to get that done, we can use this item score. We can use it because this is a matrix of the responses of the correct and incorrect response, so we could use it. So let's just copy what is here and put this particular one here, this one, item score. That is what is taking the matrix of the responses, correct and incorrect responses of our respondents. So just come put it inside this place. Put it inside here. So reliability item score. The item score here, the reason why we are using this particular one is because it's the one that is containing the matrix of the item response, the correct of the item of the scored item responses. So without wasting time, we are good to go. Let's quickly run this analysis. Let's run it. So you click run. Now we can see reliability analysis, you will find additional option and better formatting using item analysis. Yes, so we are still going to look at that, but we just want to see the output for the reliability analysis. So for us to see the outputs, you then type the name of the analysis, which is reliable. Here is it. We'll press enter. So we have 60 item, 199 examinees, and then the coefficient alpha is 0.79. So that is the overall reliability of our tests. Now the next thing we want to do is that we have to go ahead and then look at the distractor analysis. The major reason why we are using this, one of the major reasons why we are using this package. So let me call this distractor analysis. Now, how do you do that? What are the things you need? The code for your distractor analysis So we'll write the code. So the first thing you want to do when you are typing any analysis, any code, is to give it a name. So let me call this one this. Maybe I just call it distract underscore anan. Less than sign. Put hyphen in front of it. So the code for the job is type distract. So there are two there. Each of them, this one is the deprecated one. The function is deprecated. The is where it started from, but this is the new one that is correct. So it's distractor analysis. So distractor. So you just select this one. After selecting this one, the first entry is your data. It's the data itself. So the name of our data file is phy. Then the next thing that should follow should be the key. And the name of our key is simply key. You can see here, key and comma. So the next thing that will follow is that you want to tell the system to send the report, the output, into an Excel sheet. So you type CSV and it will bring CSV report. So it will show you here, it has suggested it to you. Click on it and then you now type the name, what you want it to be equal to. Then you type the name. So you put the double quotation mark, and inside the double quotation mark you then give the name. So what name do I want to call this? I can call this distract. I can call it distractor. And then dot CSV. CSV. The CSV here is small letter, don't forget. Now we are good to go to find the distractors, the quality of the distractor of this our data, phy. So highlight it and then you click on run. We are good to go. Our distractor has been analyzed. If you want to see at this point, if you check your folder that you created, you have it there already, but you may want to see what you have done here before you go over to looking at the output. Just type the distract, the name of the analysis, and press enter. So you can see analysis has been concluded. to start from the very first one. So question 1, the correct answer is B. The answer is B. So you have A, B, C, D, E, and they omitted. How many omit did you get? 1. E, 6 people picked. D, 3 respondents. C, 8. The right answer 155, and A, 26. So here you judge the quality of your distractors at this point. So you can check literature. For a distractor to be functioning well, it must attract a particular percentage of the people or of the respondents or the examiner that take the particular test. If you look carefully, you discover that these distractors, they are not functioning as they should be. Though they are functioning as distractors, but I guess they are not distracting enough. But you can check literature to check what is the acceptable standard. So you can see this RSPP that you have here is the difficulty index, the proportion of respondents that picked each of the options. This one here you have it is the point by Sarah correlation. If all of these are considered to be the answer, what is their point by Sarah correlation? That is the discrimination. Point by Sarah correlation is a measure of discrimination, and you also have the upper and lower extreme division of discrimination here, which we talked about in our last video. Now you have the lower here. This is just the proportion of the people in the lower quartile. Like you have 25 first quartile, second, the middle, the first, the middle, the 75 percentile, the upper percentile. So this is like the first 25 percentile, first 50 percentile, first 75 percentile, and the upper percentile. So what is the proportion of people that picked? 0.24 people who belong to that. So at this level you can see how it's functioning across the several score division that you have in your test. So that is that about distractor analysis. The other analysis we now want to look at properly is the item analysis itself. So the item analysis itself, alright, let's consider the item analysis itself. Let me also write the comments. Item analysis. This place we are going to be having the difficulty, the discrimination. We'll even have to ask the system to flag what the difficult item and all of that. So that's what we are asking it. We are going to do at this level. So how do we go about decoding? The first thing, you want to give it a name. So let's call this one item. Maybe you should call it item stats. Item statistic. So the major code there is item analysis. So it's going to show you item analysis. It's going to show you. So you click on it, item analysis. After clicking item analysis, here also what you need for the analysis, just like the case of the reliability, is not the data, is not the key, but the item score. The item score which we obtain here, which we obtain at this level, the item score we obtain here. So that is what is needed, just like we use it for reliability analysis. So inside here you type the item score. Type the item score, comma, and then you type item reports. item report equals to true. Okay, let's try and keep it as simple as possible. The item report is default. By default, the system will bring the report, so you don't have to type it. So that will keep it as simple as possible. So the next thing you want to type is what is the standard what is the standard that you want to use to decide if an item is difficult or if it is easy. What are you using? So the very first one is for the case of when it is difficult. So I am using, there are several rules for classical test theory, but the one I want to use is 0.2 to 0.8. If it is 0.2, it is difficult. So I'm saying that if it still sits at 0.2, you should consider it as difficult. Also, I will type 0.8 for difficulty, 0.8 for when for easy item, then the point by serial correlation, which is a measure of discrimination. What criteria do you want to use to judge if it's difficult or if it's discriminating well or not discriminating well? So I am going to also use 0.2 and the biserial correlation. So the point biserial correlation is actually what we want, but you can as well put the biserial correlation depending on what you are using, but we are trying to ensure that all of the output is printed. But the point biserial correlation is what we use as a measure of discrimination, as a measure to assess the quality, how discriminating the items are, or the item is rather. So then for biserial, I'll also use 0.2. After that is done, we are good to go. So three important codes that you need here. After you give it your name, the name of the analysis, the next thing is this less than sign and hyphen, which is to demarcate the name, to differentiate the name from the code. The next code is the item analysis, the item score that we obtained from the test score, and then the standard for judging hard, difficult item, easy item, the standard for judging the discrimination using point biserial, and the standard for judging discrimination the biserial correlation. So after that is done, your analysis is ready. You can click on the code and then run. If it runs well, then you don't have issue. There is something else we have to do here, like we have been doing for us to obtain the output. If you just copy what you have here as your item statistics, if you just type it, which is the name of the analysis, just type item statistics. Item statistics, and press enter. What is going to show you is just going to be what you get from your reliability analysis. That's what it's going to show you. So for you to really obtain the item analysis report, then you type item statistics, you type item statistics and put $, and then in front of the $, type item report, and then click on it and click run, so you can see what we have. So it will give us, and see, this is the item name. Item mean is simply the difficulty, the point biserial correlation, the biserial, and also is now giving you the Chrombar chart, the reliability of the test if this particular item is deleted. That is, if we remove item 1 from this test now, the reliability of our test, which was 0.79, will be dropped back to 7.84, which means this particular item is very important. apart from the value. But if you, the reason why this is important, if you check here, you can discover that the difficulty is falling within the range where it's acceptable, and the point bilateral correlation is also falling within that range. The point bilateral correlation that you have here is also falling within that range. This one is like what we have in the psychometric package, the point, the item total dot, the item total relationship, when the particular item, when the contribution of the item to the total score which was correlated with has been removed. That is the point bilateral correlation. Why the bilateral correlation is when the contribution of the item is included. This is the actual thing that should be used. So if you look at it, you can also see where you have the judgment of whether the item is hard or is simple. In this case now, you can see it's showing us that the item is hard. Why? Because the difficulty is 0.1 is less than 0.2. That's why it's saying that this item is hard. So what you pick in your test depend on you. If I'm doing a test that I want it to be so difficult, I want only very few people to answer the item correctly. If I'm using classical test theory, I'll go for this very difficult test item. So what you select for your test is solely depend on the purpose of your test. So you can see these are items that are highlighted to be hard, and then there are no easy one. You don't have easy. It's not easy. What we have is just only the hard. We don't have items that have difficulty that is greater than 0.8. That is why the easy label is not included in the output. So that is that about your item analysis output. So this particular output is important, so you should be interested in printing it out into your folder so that you can use it for your report. So how do we print out into our folder? It's simple, the output. So you just type sync, open your open brackets, put the double inverted comma quotation mark. Inside the quotation mark, put the name you want it to be. So I'll call this one let's call it item statistics possibly, or we can just call it item analysis output. Item analysis, and then put the extension you want it to be presented in .txt, free text format, and press enter. Then the code that we use to extract the item report is simply item statistics $, and then item reports. After that is done, you press enter, and then you then type sync and close the bracket. So to get this done, typing here does not mean the analysis has been done. This is just where you write your code, and then you have to highlight everything that relates to the output so that you can get it done. But let me just put the code here because I want to attach this to the video so that you can practice with it. Extracting item statistics, output. So for us to get that printed out in our folder that we created on our document desktop, we have to highlight the lines of the code that will make this happen. This first one is to create a file inside our folder. The name of the file is item analysis, and this .txt is just the extension in which the type of file that will be created, which is free text format. Then item underscore statistics is the name of the analysis for the item analysis, and then we use this $sign to extract the report, and then this sync is to put an end to, is to close the file that were created after the item report has been printed into it. So we highlight and then click run. After that is done, our output would have been created inside the folder that we have on our desktop. So let's now do the last thing for this video, which is extracting the item, printing the item characteristic curve for each of the items to just visualize the behavior across the various test score. So two things you are going to need for this analysis is you will need the test score, and also you will need the item score to plot this, because it's a graph of total test score against item score. So let's get this done. So the code is CTT ICC. So we can see here it's suggested for us, so we click on it. So what is the name for our item score? Can we remember? For our test score, this is our test score, this is the name. Test score, total score, TOT. So that is TOT underscore, that's the test score, comma, the item score. The item score. And then one other thing that is important, the item score, you have several of them. So which of them do you want to plot against the total score? So you use this square bracket to get it done. But then let's plot for the very first one, put comma and put item 1. So that means we want to plot the score, or the responsive score on item 1 against the total score. So you click, you highlight it, and then you click on run. That is done, so you can see the item characteristic curve. This is the difficulty against what? The total score. So you can see it was moving up. So as the difficulty, as the ability of the person increases, the probability that is going to answer the item correctly. So you can see as the difficulty increases, ability, so it means that people who have higher score will be able to answer the item correctly. As the probability is increasing, those that have higher score will answer the item correctly. But at total score of 20, you can see the test is behaving almost the same way for participants. So if the ability is high, you can see the ability at 0.8 here, 0.8, it will take people around this ability, around this score, to be able to get the item correctly. So that is that about the item characteristic curve. So if you want to plot for item 2, all you need to do is to write the same code and change this one here to 2. Change it to 2, and then press enter. You can see this is the item characteristic curve for item 2. We have come to the end of what we have for us in this video. Thank you so much for seeing my channel. For more videos, try and subscribe to my channel, and also write your comment below if there is any other thing you want me to do that you don't understand or you would like us to make video about. Kindly put in the comment section. Don't forget to hit the subscription button, and I'll see you again in our next video. Thank you.